Hello grade levels. Let's look at this question 4. This is what we're going to work on this lesson. So if this is your first time watching our lessons, please make sure that you hit the subscription button so that you don't miss the next lesson. By joining the family, will make sure that you feel at home. So on this question 4, they say that we are given two function, which is f at x, it's a straight line, and g at x, which is your quadratic function. They tell you that the graph intersect at O and P. So I'm just going to highlight that to show that this is my point of intersection. So we don't know the coordinates of P, but we already know that this O will have the coordinates 0 and 0 because this is at the origin. So let's see what we have on the questions, right? Calculate the coordinates of P. What is the coordinates of P? The point of intersection, where the two graphs meet. To calculate the point of intersection for A, you need to take the two equations, equate them. So to find the point of intersection, we need G at X to be equals to F at X. So when you have it like this, you need to go and check what is G at X equals to. This is X squared. And what is F at X equals to. So if we check on the graph, F at X is given as 2x. So we need to equate this to 2x. Then let's solve for x. So the best way to do this, let's move the 2x to the left hand side. So this will give me x squared minus 2x, and this is equated to 0. To solve for x here, let's take out that x as a common factor. So we can write this equation as what? X into x minus 2. Then this is 0. So this is a zero product property. Zero product property. We can use the zero factor law to solve for x. We take this first x that is outside the bracket, we equate that guy to 0, or the value of x will be equals to what? Will be equals to 2. Remember that already we know the x coordinate of what? Of O. So this tells you that this x is equal to 0 is for that O, because the x there is 0. This x, it will be the x coordinate of P. This will be 2. So to find the corresponding y value, what you need to do, you're going to take one of these equations. So I'm just going to take g at x. We know that g at x is y, it's equal to x squared. Where this x, we substitute that 2 to find what? The corresponding y value of P. So this will be 2 squared, it's equals to 4. So therefore the corresponding y value of P, it's for the coordinates of P becomes 2 and positive 4. And that's it for this lesson, for this question. That's it for this question. So let's substitute the value of P there. So this will be 4, and I'm happy with that. So look at the next question. By using the graphs, we need to answer the following question. Look at this graph and tell us what is the domain of G at X. So G at X, if you look at the graph of G, this is my graph of G. That graph is a quadratic equation. So it takes all the positive and all the negative x values. So as you can see, it takes all this positive, all this negative values, and it also takes all those positive values. So the domain, its x, must be an element of real numbers, and you just have to give it like that, and you're definitely gonna get that 1 mark. So the next question says, determine the values of x for which x squared is greater than 2x. So I'm just gonna put this in a simplest way that it will be easy for me to understand this question. I know that x squared is my g at x. So the question is asking, where is g at x greater than? So where is g at x greater than 2x? That's f at x. So where is g at x greater than f at x? Right, let's go on the graph and try to see where it's f at x greater than where is g at x greater than f at x. So look at this. When you see this type of question, they are asking, where is g above what? Above f. Where is g above f? You go to your point of intersection. This is my point of intersection. This is also my point of intersection. You're going to look, where is g above? So can you look at this? Go in that side. The graph of g, it's above that f. It's above. And then from this point, go in that side. The graph of g, it's above that. So it's above from this x coordinate going in that direction. So x must be less than 0. You're going to say x must be less than that x coordinate of what? Of the point of intersection. Then you do the same. It takes from this point going in that direction. So or the value of x must be greater than that x value of the point of intersection. So this will be greater than 2. So the answer for this, x must be less than 0 or x must be greater than 2. That's how you answer this one. X must be less than 0 or the value of x must be greater than 2. And that's it for this one. So now, for which values of x? It's g at x less than 0. When we say g at x less than 0, we are asking, let me quickly explain this. G at x less than 0, this means that where is g at x? Where is g below the x axis? Because they are asking you where it's y negative. Does g have the negative y values? No. The graph of g is just concave up and it tends at 0. So we don't have any negative y values. This tells you that there's no x values. So the answer for this one, no x values. There's no x values where g at x is negative. There's no x values where g at x is below the x-axis. So this tells you that g only takes all the positive y-axis. There's no negative. So there's no x value that has what? Negative y value. All of the x value will contain positive y values, because look at how the graph looks like. I hope that was an easy one, Magnet. Now the last one, determine the equation of h at x. This is f at x. This is easy, né? Don't stress about that. Just take these 2 marks and say f at x. What is your f at x? It's 2x. So your f at x, it's 2 what? 2x. So to work on this, we're just gonna say my h at x is equals to f at x, it's 2x, then you add 4. This is the new graph that we formed of h at x. Ladies and gents, that's it for this question. This was an easy question paper.